This is a minute miner, a clock that counts every single second, exactly on time. Let's see how it works. As you can tell, it counts pretty well. But the best part happens right now. This is the clock on the final PCB. This marvel of technology produces a pulse every 0.999 seconds. What you've just seen is the application of the first of four main parts of this build: the 1 Hz time base, BCD counter, BCD to 7-segment decoding, and the 7-segment display. Let's quickly run through each of these. The first part being the accurate 1 Hz pulse for the display. To do this, we need a pulse generator. Let's have a quick look at the schematic. As you can see here in the top left, this part is what actually generates the pulse. To get an accurate clock, we need something called a 1 Hz square wave. Unfortunately, while this does produce a square wave, it's not 1 Hz. In fact, it's at 32,768 Hz, which is a bit off. Despite it being so far off, because of its nature, it's 2 to the power of 15, which means we can simply divide it using chips. This is also exactly what the schematic shows. It uses these chips here and here to divide the frequency. It does this using counters and taking the output from the final layer. Now that we have our 1 Hz signal, we need something that actually does the counting for us. And for this, we use BCD, or binary coded decimal. In normal binary counting, it goes like this. Each digit, as you can see, pulses at half the speed of the last, and this keeps on going forever. So instead, we use BCD counting. It's the exact same, except once it reaches 9, it increments the next clock. The main problem is that we want the second clock to reset after reaching 59. Fortunately for us, by making smart use of an AND gate, we can easily do this. Let's start by removing these lighter numbers. Then we use an AND gate to check if the values here and here are both equal to 1. If it's true, then we reset the count. This makes it infinitely easier for the next step, which is to decode the values into something that the 7-segment display can actually read. 7-segment displays aren't actually as complicated as they seem. They're, in fact, just 7 LEDs strapped in a specific way. They have no sort of internal logic of any sort, so we need to do that for them. This is the 7-segment decoder, and it works exactly as it sounds. It takes the 4 inputs and turns them into 7 outputs, each of which correspond to 1 LED on the display. If we use 2 of these, we can link one up to each of the different digits in our 7-segment display and create our final clock.